Okay, so what we're doing today is just a continuation of what we started yesterday. But today the problems that we're going to be working on, some of them have what's called extraneous solutions. So extraneous solutions are solutions that when you plug them back into the original equation, they don't work. So you solved everything right, you did all your work right, and you got these extra numbers basically. All right, so for example 4, we are going to solve x plus 1 is equal to the square root of 7x plus 15. So they've already isolated the radical on the right side, so I can just square both sides. And so I get x squared plus 2x plus 1 is equal to 7x plus 15. Remember, when you're squaring a binomial, that's x plus 1 times x plus 1. So make sure you guys remember that you have to distribute everything. It's not just going to be x squared plus 1, but you have a middle term, okay? All right, so then I would subtract the 7x and subtract the 15 from both sides so that it equals 0. And I get x squared minus 5x minus 14 is equal to 0. And so now I have a trinomial that can be factored, so I'll go ahead and factor it into two binomials. What's it going to be, guys? Right, x minus 7, x plus 2. And so that means that x is either going to be positive 7 or negative 2. But now I have to go and check those solutions in the original equation before I squared both sides. So let's erase that so I don't confuse you. All right, so I'm going to plug those answers in. So first I'll try the 7. So 7 plus 1 equals the square root of 7 times 7 plus 15. So 8 equals the square root of 49 plus 15. And 49 plus 15 is 64. And so the 7 works in the equation. And then I'll test the negative 2. So I have negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. So negative 1 equals the square root of negative 14 plus 15. That simplifies the square root of 1, which is 1. And negative 1 does not equal 1. So that means that that negative 2 was actually an extraneous solution. And the only solution that works is the 7. Any questions so far? Okay, so when you finish copying that down, here's one for you to try on your own. The square root of 10x plus 9 is equal to x plus 3. All right, so most of you were doing okay with initially. You got the x squared plus 6x plus 9, and you got down to where 0 was equal to x squared minus 4x, and then some of you kind of got thrown off by that. When it's not a trinomial and it's not the difference of squares, you just take out the greatest common factor. So x times x minus 4. So that means either x has to be 0 or x minus 4 has to be 0, so that would make x positive 4. Then when you go back and plug them in, we get 10 times 0 plus 9 under the radical, and then 0 plus 3. So we get the square root of 9 is equal to 3, so that one works. And then if we test the 4, we have the square root of 10 times 4 plus 9 equals 4 plus 3. So that's the square root of 49 equals 7. Oops, that was supposed to be an equal sign. And so that one also works. So you're not always going to have extraneous solutions. Sometimes they will both work, but you're not going to know unless you test both of them. Can you test only one of them? Can you test only one of them? No, you have to test them both, okay? You can't make any assumptions based on whether one of them works. All right, so now we're going to do a problem where we have radicals on both sides. So it's a little bit harder to isolate when you have two of them. So the first thing we have to do is isolate one of the radicals, square both sides, and then we're still going to have a radical left. Then we'll isolate the one that's left over. So the first thing I'm going to do in this case then, since I already have one of my radicals isolated, is I'm going to square both sides. I'm going to take the square root of x plus 2 plus 1. I'm going to square that. And the square root of 3 minus x, and I'm going to square that. So what you have to remember is, again, you're using the distributive property. You're taking that x plus 2 plus 1 times the square root of x plus 2 plus 1. You're timesing it by itself. Oh, I wrote that, so I put my 3 minus x a little close together there. But anyway, so you have to use the distributive property. And so the square root of x plus 2 times the square root of x plus 2 is just x plus 2. And then the square root of x plus 2 times 1 is the square root of x plus 2. And then I use my 1 to distribute, so 1 times that, I get another square root of x plus 2. And then finally, 1 times 1, I get 1. And that is equal to the 3 minus x. So now I can combine my like terms. I've got 2 and 1, so I'll add those two together and get 3. And then I also have 2 of the radicals, so plus 2 times the square root of x plus 2, and that's going to equal 3 minus x. So now I need to isolate my radical that's left over, the square root of x plus 2. So in order to do that, I'm going to subtract the x and the 3 from both sides. And on the right side, my 3's actually cancel out, so I'm left with 2 times the square root of x plus 2 is equal to negative 2x. Because negative x and negative x is negative 2x. And then if I divide both sides by 2, I get the square root of x plus 2 is just equal to negative x. Now to get rid of that radical, I raise both sides to the second power. So I have x plus 2 is equal to x squared. I subtract the x and the 2 from both sides. And so I have 0 is equal to x squared minus x minus 2, and now I have something I can factor. And it ends up being x minus 2 and x plus 1. So that means that x could be either a positive 2 or negative 1. But now I have to test to make sure that they work in the original equation. So 2 or negative 1. So going back up here where I can see it. If I plug in a 2, I've got the square root of 2 plus 2 plus 1 equals the square root of 3 minus 2. So that's the square root of 4 and the square root of 1. But 2 plus 1 does not equal 1, does it? So the 2 is extraneous. I know the 2 is not going to work. Now I try my negative 1. So the square root of negative 1 plus 2 plus 1, square root of 3 minus negative 1. So 3 minus negative 1 becomes 3 plus 1. And so I have the square root of 1 and the square root of 4. And does 1 plus 1 equal 2? Yes, it does. All right, so I know that my negative 1 works, and that's my solution. Okay? All right, so when you guys are done writing that down, I have one for you to try on your own. All right, so as I was walking around, it looked like most of you were getting there eventually. After you distribute, when you square the left side, you should have gotten x plus 6 minus 4 times root x plus 6 plus 4. And then if I combine the 6 and the 4, I have x plus 10 minus 4 times the square root of x plus 6 equals x minus 2. Then you subtract x and 10 from each side. And so you're left with negative 4 times the square root of x plus 6 is equal to negative 12. And when you divide by negative 4, you get the square root of x plus 6 is equal to 3. Square both sides, x plus 6 equals 9, and so x equals 3. And then you can go back and test that in the original equation. So the square root of 3 plus 6 minus 2 equals the square root of 3 minus 2. And so I have the square root of 9 minus 2 equals the square root of 1. 3 minus 2 equals 1, and it works. All right, so no further questions? Oh, yes? Does it pertain to the lesson?
Yeah.
Okay.
It's kind of like you have to like do two things. Like after you got the problem written down, and then you got the.
I squared it.
How can you do that?
To get rid of the square roots. To undo square roots, you have to square something. Okay? All right, that's it for today.